now that the major engine parts are disassembled, I'm going to do various measurements on them to check whether they were in tolerance, so looking for any wear, seeing what needs to be replaced and what can be reused. First things I'm going to measure are the valves. I'll be looking for wear on the valve stems. So here on the stems they can have taper, so basically a difference in measurements between the top and bottom, and also just wear where the diameter is reduced all along the length of the valve. So I'm going to measure that using a micrometer. So the first thing I do with the micrometer is just check to make sure that the 0 is set, so just close it up, they can see that's set to 0. And then I'll just do measurements at the top, middle and bottom. So just bring it up on there, you can see 5.93. Again 5.93. And there 5.929. So I'll repeat that for each of the valves for the intake and the exhaust. The next section I'm going to measure are the conrods and also the big end journals on the crankshaft. So I've measured the journals on the crankshaft. That was done using this micrometer. This is a 2 to 3 inch micrometer. It works exactly the same way as the 0 to 1, except for setting the 0 position you have a distance piece here. So you close it up on there and set the origin. Then I measured the journals at different angles to check for any ovality in them and measured them across the length of the crankshaft just to make sure that they're all the same and they're within spec. So I'll show you the details of that later. Then moving on to the conrods, there's a couple of different measurements I'm taking here. So these are the bearings from this particular conrod. As you can see the bearings there. So when the bearings are installed in the conrod like that, I'm checking this measurement across here. So that's making sure you can see what the clearance is against the crankshaft. And then once the bearings are out, I'm measuring this dimension here and also this dimension across here. This is looking for ovality in the conrod, because these conrods are made out of titanium and they can stretch in this dimension and they can also go oval here. So the measurements for doing that are done using a bore gauge. This is the bore gauge here, consists of a dial indicator and some distance pieces. So to set it up, the correct distance pieces have to be selected. You see there are some spacer washers at the end and they screw into the end of here. So I'll just quickly set this up. So I just need to see approximately what size these bearings are, so I can just measure that around here. Right, so they're supposed to be 56 millimeters by the looks of it, so I need to set this up to 55.9. So I'm going to use a 55mm and a 0.5 mm spacer. I have to fit the dial indicator. So see, this is fitted until it just moves slightly on there. So we know then it's engaging. So that's done. And then we need to set the dial indicator up for the dimensions of this. So this is 56 millimeters, so I have to set up my micrometer to 56 millimeters. So firstly I shall 0 it. So there you can see that's already showing 50.799, it should be 50.8, so I'll just set the origin on that. And then I need to set the micrometer to 56 millimeters. So this is going to be the reference for our measurements. So I have to very carefully set this up. It takes a little bit of time to get it just right. And then lock it in position so that it won't move. So you can see that's set to 56. Now ideally this will be done in a micrometer stand for this, but I haven't got one here, so I have to do it without. And I then use the bore gauge to set this up on here. So as you'll see on here, as I move this backwards and forwards, the dial moves. So I'm looking for the maximum point on the dial, which will be achieved when it's going straight across, and then I turn the indicator on here so that it goes to 0. You can see on here that is going to maximum at 0. So that is now set to 56 millimeters. So now to measure a conrod, put the dial indicator in here and then move that up and down to give an indication. Now that's showing around 60. There's a maximum on there, so that's 60 or 58 thousandths of a millimetre in that dimension. And in this dimension, you can see it's going up close to about 6 or 7. So it's 6 or 7 thousandths of a millimetre in this dimension. So it's around 50 thousandths of a millimetre or 500ths of a millimetre larger. So that's the ovality on it. So that's how I measure the ovality on those, and the diameter. So I measure all of those a bit more slowly and carefully than I'm doing for this video, and then noted those down. And then when those are done, move on to doing the pistons. These were all actually measured before I took the liners out. So for doing these, I measure the diameter of the piston, which is measured across the centre of it just there, so not at the bottom, not at the top, but basically at the largest dimension across there. And then also use the bore gauge to measure the diameter of the cylinder. So that's measured at the top, middle and bottom, across the thrust faces that way, and also across side to side, so again checking for any ovality in the cylinder. So I did all of those measurements, noted them all down, and now I'll give you a quick run through of them. These are the results of the measurements. I started off looking at the big ends. These are the measurements on the big end journals on the crankshaft. Number 1 being furthest away from the flywheel, number 6 being at the flywheel end. There are 2 measurements, one in the direction of thrust and one at 90 degrees to the direction of thrust, so we can see any ovality in the big end bearing journals. So as you can see, the measurements are all within specification. There's a bit of ovality on each of them, and they're all above the minimum spec for the measurements on the crankshaft. Then moved on to actually measuring the bearings themselves. So with the conrods removed from the crankshaft with the bearings still fitted, the red dots here show the clearance between the bearing and the crankshaft, so they're all down towards the bottom end of the range, so there's no high clearances on these, so there wouldn't be any oil pressure issues from these. And then taking the bearings out of the conrods and measuring the diameter of the conrods, can see the ovality on the conrods where they've stretched. So the blue dots here are the measurements in line with the thrust, and the red dots are the measurements across the joint. And the green dots here, which use the scale on the right hand side, show the ovality. So we're up to about 0.04 to 0.05 millimeters of ovality on the conrods. So that shows the stretch on them. Moving on to the main bearings. So main bearing 1, furthest away from the flywheel. Main bearing 7 is the one next to the flywheel. And we can see the clearance or the diameter on these journals increasing as we go from 1 across. They're all above the minimum specification. You can see the clearances on those. And then going from there to look at the actual diameters on the bearings and the clearances. So we'll see that number 1 has a very low clearance on it, and that's caused by having a small diameter on the bearing. So there's something going on 1. It's measuring 0.008 millimeters of clearance. The lower limit is 0.01, so it's 0.002 of a millimeter underneath. That's probably within the errors of my measurements. In fact, I'm sure it will be. So I've spoken to an engine builder about this, who said he wouldn't be particularly concerned about that, but it is something I'd certainly look at. All of the others are right in the middle of the range, so around about 0.04 millimeters on the clearance. So these blue dots are the actual diameter, so you can see most of them measured just over 60 millimeters, apart from one which measured slightly under. So I took the bearings out of the case and measured the diameter in the case of the actual machining in the case, and there you can see that number 1 and number 7 are both measuring a small diameter on there, smaller than the others, and that corresponds with the main bearing measurements for the journals on the crankshaft. So I'm assuming that the crankshaft wear is in line with the clearances on the bearings. So this is something I'll certainly be looking at before rebuilding, whether it's an issue due to tolerance stack up, that by selecting bearings we can get better clearances or whatever. I don't know, yet to look at that, but there's certainly something going on in here. So the number 7 is showing 0.05 millimeters smaller, and number 1 is showing 0.03 millimeters smaller, so I have to be super careful on the clearances there. Moving on to the cylinder heads, looking at the stem diameters on the valves. The inlets are all showing some taper. The green dots here are the measurements on the bottom of the valves, at the bottom of the stroke. So we can see that some of them are showing more taper than others. Number 4 is particularly bad, with around 0.025 millimeters. Others not so bad. The exhaust valves, if you look at the scale on here, you'll see that the exhaust valve stem diameters are all smaller than the inlets. I'm yet to confirm this, but I believe that's probably by design, because I know the exhausts do run a larger clearance on the guides. I will be measuring the guides, but haven't done yet. There's less taper on the exhaust, which would make sense if they run more clearance, so there's probably going to be less wear on them, and they're more consistent in their measurements. I've only measured one head at the moment. I'll be disassembling the other head to measure those. Then finally, moving on to the clearance on the cylinders. This is the piston to cylinder wall clearance. This is in the up-down direction, so this is where the thrust is trying to expand the cylinder to push it apart. So we can see that the clearance at the bottom is greater than the clearance at the top, so the bottom of the cylinders is being pushed outwards, except for number 4 and number 6, where there's very little movement on that. And this pattern is repeated in the opposite direction, looking side to side. So they actually taper inwards towards the bottom when measured side to side by around about 0.03 of a millimeter on that. except again for 4 and 6. So I do wonder when this engine was previously rebuilt if maybe 4 and 6 had new cylinders put in. So those are the measurements done so far. I will be checking the valve guide diameters and also doing the measurements on the second head, and I'll be investigating what I can do with regards to the machined holes on the block and whether we need to do any different machining on that.